All right, so 6.3, factoring trinomials of the form ax squared plus bx plus c, and that's what we call our standard form, and perfect square trinomials. And we're going to get to perfect square trinomials, and that's kind of what this is off to the side, so we'll get to that towards the end of the video. But what you got to understand is this is the difference between 6.3 and 6.2 is you will have a number in front of this x squared. Okay, so even if you factor out that GCF, sometimes you're still going to have a value here. And when you do have a value here, the way you solve this is a little bit different than the way maybe we were doing it in 6.2. All right, so, and I'm not exactly sure how my math lab explains it, but the way we do it is we're gonna solve it using grouping. Okay, and so the first thing you do is obviously you want to look to see, is there a value that I can factor out? Is there a GCF I can factor out? In this case, there isn't. There is not a number that goes into both 5, 34, and 24. Okay, so what we do is once we determine there's no GCF to factor out, what we're going to do is multiply our A value and our C value together. In other words, so the A in this problem would be 5, and the C, the constant, would be 24. So we start out, we do A times C, which would be 5 times 24. Okay, and now 5 times 24 gives me 120. All right, so what we're going to do is we would then find all the factors of 120 that would come back to 34. Now, that is going to be kind of time consuming. So what you'll notice in the PowerPoint, I'm also going to try to put a little hyperlink to the video, and when I send out an email, I'll also include this program as well. There is a website that I'd encourage you guys to use. And it's mainly with the homework, because the actual practice tests and the tests are not going to give you factors that are this large that are going to require this much work. Okay? But in the homework, they do give some pretty crazy type problem. So what you do is once you multiply the A and C, remember in the last problem we got 120, we're just going to come to this program and put in 120 and then calculate. And it will it'll tell you all the factors of 120. All right, so it's our answer, or what we're looking for, is going to be one of these. And if you remember going back to the problem, this middle value was 34. So we're looking for the factors of 120 that when they add together, they give me 34. Let's go back in there. And hopefully you're able to notice that 4 times 30 multiplies gives me 120, and when I add 4 and 30 together, it gives me 34. Okay, so remember that, write it down. It's going to be that 4 times 30 is what we're going to use. So now you're going to come back to your problem, and where you see 34, we're going to actually rewrite 34 using these two values. Okay, in other words, we're going to write 4x plus 30x. And if you notice, 4x plus 30x is 34, right? So we're just rewriting really the value of 34 here. And then we're just moving down the first term, which is 5x squared. And since that 4x is positive, we're going to put a plus. And then we're going to move down the plus 24. So if you look, what we did was we took the trinomial, and after finding the A times C is 120, and then the factors of 120 that give me 34, 4, and 30. And so we took the trinomial and we're rewriting it into a 4-term polynomial. There's 4 terms here. All right. And now, once we've written it in 4 terms, what we're going to do is we are going to use our grouping that we learned in 6.2. So we're going to group these. and then factor out our GCF after we group them, okay? So looking at that first one, my greatest common factor, looking at the coefficients, there's not a number I can pull out, but they each have an x. So I'm going to factor out an x, and I'm going to be left with 5x plus 4. All right, now the key is this sign right here between the second and third term. If it's positive, then you just go ahead and write a plus. But if it's negative, that means I have to factor out a negative GCF. But in this case, everything's positive, so we're just going to keep it positive, which we'll show examples of if I do have a negative there. And then looking, what is the GCF here that I can factor out between 30 and 24? The highest number they both have in common is actually 6. And when I factor out the 6, remember I'm dividing 6 into both of these, I'll be left with 5x plus 4. Now, a very big indicator that we did this right is this right here. If you notice, they have the same binomial here, 5x plus 4. If you remember our grouping, once we have that same thing, we factor that 5x plus 4 out. And then we're left with x plus 6. And we are done. If we're in a test setting, you maybe want to factor it all the way back. But when you do factor it all the way back, it'll come back to 5x squared plus 34x plus 24. So that's how we are going to do these. And we're going to do, like I said, a bunch of examples of this. So hopefully you'll start to understand kind of what we're doing. And, just going to require a lot of practice, a little bit different. You always would rather these not have a value there because it's a little bit easier to solve. But you can use this grouping form even if there wasn't a value there. You just use it as a 1. And that's basically what we're doing because we're doing just the value of c. Well, if you did multiply the 1 times c, it would still be c. All right, but you could always solve those using grouping as well. All right, let's get into another example. This one's going to be similar. The only difference here is you're going to have that x and y's in there. But that's not really going to change how we solve them. It's just going to change what that answer looks like. All right, but again, you always want to look to see, can I factor out a GCF? And you're going to be tempted to think you can with the variables, but remember all the variables, even though these two have an x, it doesn't have, this one doesn't. And these two have a y, but the first term doesn't have a y. So I can't factor out any variables. And there isn't a number that goes into 21, 17, and 2, okay? So there's not a GCF I can factor out, so I can just kind of start working it. So again, we're gonna do our A times our C value. I'm doing 21 times 2. And 21 times 2, so again, 21 times 2 would give me 42. And just remember with this type of problem, with this being negative here and this being positive here, we know that they're both going to be, these values that give me 42 are both going to be negative. All right, so you can work it yourself if you want to, because that's kind of a smaller value, or you can go to that website that I was sharing with you and just put in 42. Again, we're looking for the factors down here that will add up to 17. And we see it right here. 3 and 14 would add together to give me 17. But remember, they're both going to be negative. So it's negative 3 times a negative 14. So when I rewrite this negative 17, both values are going to be negative. Now, one thing I want you to remember is, it's xy. So it's negative 3 xy minus 14 xy. And then we'll move down the first and last term. And that's a plus that kind of comes with it. And we move the 21x squared down. We knew that it's negative 3xy and negative 14xy. All right, so once we've done this stuff and we've rewritten negative 17 using these values we found, we will use our grouping. Start here. We look at 21 and 3. That means they have a 3 in common that I can factor out. With that first value being positive, I'm going to factor out a positive value. They also have an x in common, so I could also factor out an x. So when I factor out that 3x, I'm going to get 7x minus, now the 3x's are going to cancel, so I'm going to be left with the y. Don't forget the y that's still there. And again, what I'm doing is dividing that 3x into both of them. I don't always write it up there, especially with my little grouping signs, because it gets a little sloppy. That's what we're doing. Now this is really important, what I want you to notice here. The sign between the second and third value is negative. So I have to factor out a negative value whenever that sign right here is negative. If it's positive, I'll factor out a positive value. But when I'm factoring out my GCF, I'm going to factor out a negative. What's the greatest common factor of 14 and 2? And that would be 2, biggest number that goes into both. And then I'm looking at the variables. Which variable can I factor out? I can factor out a y. They both have a y in common. So I'm going to factor out a y. And again, so now when I want to see what's left, just remember I'm dividing negative 2y into both of these. So remember, this negative and negative, this value is going to be positive. 14 divided by 2 would give me 7. Took the y out, but the x remains. So I have a 7x there. Positive by a negative, so I know that that's going to leave me a negative. 2's are canceling out. There was 2 y's. I took one out, so there's going to be 1 y left. Again, how do you know that's right? You'll notice that you have the same binomial here. Then you just do the last step of grouping. You factor out that common binomial, and then you, whatever's left, you put in a binomial too. So very similar. The only thing, like I said, normally you don't have that a y with it, but they'll give you some of these where you'll have x and y's, and you'll have to factor these as well. Next example. So where we know something's a little fishy is we see that 12x to the third. We don't normally have an x to the third, right? We have like an x squared here. And all that, basically when I see that, that tells me I'm going to have to do factor out my GCF. So is there a number that goes into both 12, 55, and 13? There is not, because really we call 13 is like our prime. The only way to get 13 is 1 times 13, and 13 is not going to go into any of these. But hopefully you notice that they all have x. So we can pull out an x. And that's going to give us 12x squared plus 55x plus 13. All right, so we pulled out the GCF, but now we have to factor this trinomial. So for now, we're kind of going to forget about that x. We're just going to remember that my answer must include that x first. Okay, but now we're just focusing on this trinomial and how we factor this trinomial. Again, since we see a value besides 1 in our a spot, that tells me we're going to use the grouping method. And a grouping method starts by multiplying a times c. So 12 times 13. And 12 times 13 gives me 156. Now you can go there, sit there, and come up with all the factors of 156. Or, again, there's a website that will actually do these factors for you. And I'm looking for the factors of 156 that add together to give me 55. That number, that b value is 55. So I'm going back to look for the factors of 156 that give me this give me 55. And again, it's right here. 3 times 52. And everything's positive, so it's a little bit easier. So that 3 times 52 is what I'm going to use to rewrite 55x. Don't forget, you got to put those x values in there. 3x plus 52, come back to 55, move down your first and last term. Okay, now it goes back to 6.2, where we have to factor by grouping. GCF between the first two terms is actually 3x. And that'll leave me 4x plus 1. Again, because I'm pulling out the whole 3x. Remember, we got to put a value in there. And these are a little different because we don't normally see 52 and 13, but actually 13 will go into 52. And it goes into it 4 times. So it'll be 4x again plus 1 because we factored out the 13. Good sign is those two are the same. If they're not the same, something's wrong. So that's what we factor out. And then we have the 3x plus 13. All right, our next example here, before you, we see we have an a value, and you may be tempted to just start doing a times c. The problem is, hopefully you recognize even number, even number, even number. So again, at the very least, we know that 2 goes into every one of these. All right, so we have to factor out a GCF first. And actually the GCF, that highest number that goes into all 3 of these is actually 2. So that's how we start out. Oh, and I just noticed, go back to this one here, number 4, sorry. So I kind of forgot about that x, and if you do that, you're going to get it wrong. I factored the trinomial, but I forgot to move that x down here. So just be careful of that. It's a mistake I would have made. I would have entered this, it would tell me it was wrong, and then I would probably remembered I forgot to bring that x down. Same thing on this problem. When I factor out that 2, and then I'm going to start focusing on this trinomial. But when I do have my answer, I got to make sure that that 2 is in there as well. All right, so continuing on, once we factor out that 2, okay, so we're dividing each of these by 2, we're going to have 11b squared minus 85b minus 24. Okay, so again, don't forget, like I did on that last problem, that 2 is going to be part of our answer. But at this point now, we're going to go a times c. So 11 times, and be careful here, this is a negative 24. So 11 times 24 negative gives me a negative 264. And remember, since that last value is negative, when we're doing the factors, we are going to have a lot more factors. But it's the same thing. We're going to put this into that program and find the factors. Again, we're looking for the ones that will add together to give me negative 85. I'm going to put negative 264. Sometimes when I enter it, it enters it a little backwards. So 264, just clear it and then do it again. So you look at all these different combinations. And again, remember, I'm looking for the one that gives me a negative 85. So if you look here, 88 minus 3 would give me positive 85. I don't want positive 85. So I want the opposite version of this. I want it where the 88's the negative. And so you come back up here, this is the one I want. So I want 3 times negative 88. Because that, when I add 3 and negative 88 together, that would give me the negative 85. So those are the two values I'm using to rewrite negative 85. I'm going to put 3b here and then negative 88b here. And if you flip these around, have negative 88b here and the 3b here, that's fine. However you want to do it. It'll still work. Again, the 3 was positive, so I have the plus there, then minus 88b. I move down to minus 24 and the 11b squared. I'm kind of going to put a little arrow here to make sure I remember my answer must include that 2 that I originally factored out. All right, so once I do this, I'm doing my grouping. Now 11 and 3, there's not a number that I can pull out, so all I can pull out here is a b. And that's going to give me 11b plus 3. And again, when I see a negative sign here, whatever I factor out must be negative. So these are a little bit more involved because I need to know what goes into the highest number that goes into both 88 and 24. Sometimes if you feel pretty confident with your work, you'll see, oh, I have 11, so I know whatever I factor out is going to leave 11 in there, right? But the highest number that goes into both of those is actually 8. Again, so what we're doing is we're dividing both of these by negative 8. And remember, since they were both originally negative, what's going to happen? They're both going to turn positive. So 88 divided by 8 gives me positive 11b. Negative 24 divided by negative 8 gives me a positive 3. We have those the same. We go 11b plus 3. And then b minus 8. That time I didn't remember. I did remember to bring down the 2 into my final answer. So I know these are obviously a little bit taller, a little bit harder, but like I said, just requires some practice. And that program actually does help out a lot. This one's fun. And again, this is, sometimes you can get away not having the program, but this is definitely the case where you definitely would want to use it. I'm not exactly sure why they give such big numbers kind of on these problems, because they don't do it on the test. They only do it on the assignments. And we'll talk about that a little bit more. So if you look at this problem, first of all, you'll notice you have 24z and then the z squareds here. So before we solve this, we have to actually write this in our standard form, in our a x squared plus b squared. So we want this 35z squared first. Okay, then the 24z. And then our constant always last. Okay. Now, look for a GCF, because that'll help make that number a little bit smaller, that a times c a little bit smaller. But there isn't on this problem. So we do have to multiply a times c. You're actually doing 35 times a negative 35. Now, we do get a nice big negative 1,225. Again, if you were going to sit there and try to find all those factors of that value, it's going to take you a little while. But we're looking for the two numbers that multiply to give me negative 1,225, but add together to give me 24. Because that's how I want to rewrite that 24. So again, I definitely encourage you to come to our factoring website, put in negative 1,225, calculate. And actually there's not as many as I thought there would be. But again, it would require, if you're going to do that yourself, it's going to require you a little while to come up with all those combinations. And again, I'm looking for the one that will add together to give me a positive 24. Okay. So if you see this 25, negative 49, that actually gives me a negative 24. I don't want the negative, I want the positive value. So I'm going to use this combination here. 49 times negative 25. So remember that 49 times negative 25 will multiply and give me 1,225, negative 1,225. But when I add these two together, I get positive 24z. So these are the numbers I'm going to use to rewrite that 24z. 49z minus 25z. Okay, then just move down, minus 35, move down the positive 35z squared, and then we do our grouping. What goes, I'm looking for the highest value that go into 35 and 49. Well, 35 and 49 are factors of 7, so I can pull out a 7. And they both have a z, so I'm going to pull out a 7z, and that's going to leave me 5z plus 7. We look here, again, both the key is this negative here. So I'm factoring out a negative 5. When I factor out a negative, it's going to make both of these positive. So negative 25 divided by negative 5 gives me positive 5z. And negative 35 divided by negative 5 gives me a positive 7. So I have that same little combination there. Let's factor out the 5z plus 7. Put it with the 7z minus 5. And we are done with that. So before we get into those perfect square trinomials, I want to give you a kind of example of really the type of problem you're going to see even on your practice test and your regular test, because you will not need that website. This is the type of the type of problem you're going to see on your test. Okay, not where we get these crazy numbers like that. So if you look at this again, we have a value here, and I can't factor it. It doesn't come out because there's no GCF involved here. All right, so I'm going to do my A times C. I'm doing 4 times a negative 5, or 4 times negative. I don't even have to go to my calculator for that. I get negative 20. So I'm thinking of the factors of negative 20. That will give me negative 8. Okay. And again, you can do these. You can write them all out. But this would be the combination. It's not that hard. 1 times 20, 2 times 10, 4 times 5. There's not a whole lot of those. But this would be the two numbers. So I'm going to rewrite the 4p squared. I'm rewriting the negative 8 with negative 10p plus 2p minus 5. And again, if you switch those values around, it doesn't really matter. But that's how I'm rewriting the negative 8 with negative 10 plus 2. Then I'm using my grouping. I can factor out a 2p here, and that would leave me 2p minus 5. Now this is a great example, okay? I look at my next set of groupings. I can't factor anything out. So when I can't factor anything out, what you do is you factor out a 1, which means that there's nothing really I can do besides factor out a 1. So it's not going to change it. But I do have to I just can't leave it blank and just say, well, 2p is a 1. No, you got to put a 1 there again. If I distribute that 1 back in, it gives me back to the 2p minus 5. So we factor out the 2p minus 5, and then we have the 2p plus 1. And there you have it. So this is more along the lines of what you're going to see on your test. All right, so let's talk about these perfect square trinomials, and that's really where we're going to see where you're going to use these values over here. So we got to talk about what is a perfect square. I wrote these down over here. When we're dealing with these square roots, it's usually one of the first things I do is just write down so we have these available. We want you to become familiar with what numbers are perfect squares. Okay, and basically what that means is if you square root 4, you get a whole number 2. Square root of 9 is 3. So these are what we call perfect because they come out to perfect whole numbers. Like square root of 20 would be a decimal between 4 and 5. But these are what we call perfect squares. And the way I could get this table is if you write these numbers down first, 1 times 1 gives you 1, 2 times 2 gives you 4, 3 times 3 is 9, 4 times 4 is 6, okay, et cetera, et cetera. And these go on forever, but I only wrote down kind of the first 13. I don't even know what 14 times 14 is, but so these go on forever. But you really want to recognize, especially these main ones here. You know, you gotta be able to look at them and say, oh, I know that's a perfect square. And the one that's a little tricky sometimes is, yeah, 1 is a perfect square as well. So let's next look at our PowerPoint. And it's really this screen here. And what you'll notice is if the first number and the last number are perfect squares, okay, and you took the square root of those numbers, and then you multiplied it by 2, it should give you the middle number. All right, and we'll do examples of that, of what we're talking about. But if you recognize these, and there's one with the positive and one with the negative, like this over here, it just saves you some time because all you really got to do is do the square root of the first, square root of the last, and because they're both your factors are going to be exactly the same. If you don't recognize it and you actually go through and do all the work, that's okay as well. Okay, it's just something that will save you a little bit of time. Let's look at our first example. Okay, so again, you just gotta kind of recognize that even though I don't see this here, this is a 1. Okay, and 1 is a perfect square. And we also know that 16 is a perfect square. If you look on, you know, kind of that chart, the 1 and 16 are both perfect squares. So what that tells you is, the way you factor it is, you just take the square root of the first one, which in this case is 1, so it didn't really change that. Square root of the last one, and then you square it. And that would be your answer. Okay, square root of 16 is equal to 4, square root of 1 is equal to 1, even though we don't write it there. And again, the way you know you have it, because 4 times x will give me 4x, and then you double it, and that would give you the 8x. So you have that form from that slide right here, where it's square root of the first, square root of the last, and multiply it by 2. But again, I think some people just choose, well, I'm just going to do it the long way, and if it comes out to the same thing, that's okay. So look at this one, it's the same type of situation. Perfect square, square root of 30, the square root of 36 would be 6. So this is just going to be x plus 6 squared. Now on the homework, it'll say factor these perfect square trinomials. So it's kind of telling you they're perfect squares. So you can do those, you know, so it tells you, so you don't really have to figure it out yourself. Here's an example where we have a negative in the middle. That just means that it's going to be, you know, whatever minus that number. It's just going to be, they're both going to be minus, right? Perfect square, square root of 9 is 3. So we'd have 3x, and then that just middle number is going to be minus. Square root of 49 is a perfect square as well, so it's 7. And again, that middle term, 7 times 3 is 21, and you double it. 21 doubled is 42. And we'll do one more example of that. Again, 25 is a perfect square, 9 is a perfect square, square root of 25 is 5. And since it's minus, it's going to be minus, square root of 9 is 3 squared. And again, 5 times 3 is 15. 15 doubled gives me the 30. So those are your perfect squares. So yep, that is one of the harder sections that we have in Intro to College Math. Just requires a lot of repetition and practice, and you guys should get a little more comfortable with that as well. Again, in all these assignments, we should be getting 100%. If we get stuck on any of them, please attend my office hours, and I can help you through it.